So the FET in GreatFET is because... Has it lost all meaning completely?
Kind of.
Okay.
But, right, it's derived from GoodFET. And GoodFET's name was derived from the MSP430 FET, which was a Texas Instruments debugger.
Right.
And the MSP430 FET was named for previous FETs that were debuggers from long ago, back when debugging was implemented by emulating the flash memory. It's a flash emulation tool.
Oh, I knew FET had some meaning. I was like, okay,
Yeah.
flash emulation tool, and then, wow, that's several removed.
And actually, it's kind of cool to go through that, because when we're doing the mass storage demo, we're basically emulating a USB flash device. We're using it as a flash emulation tool.
It's gone full circle.
It's totally gone full circle, and we can emulate all kinds of different flash devices. We can emulate a SPI flash device or an I2C flash device, or we can emulate a USB flash device, which is what we're doing in this demo.
This is going to be brilliant.
Yeah.
I love how many iterations this are. You know, let's just start there because
It's a stupid name.
No, it's a great.
It's
a great
It's
name, Mike.
Right.
and it's with one, so it goes along great with your Hak5 one and your Yardstick one and your Ubertooth one.
Yeah.
So what was the
We'll make it to someday. I don't know.
One of these days, you know. No, I got to know, Mike. Though, like, aside from that brilliant story, that's the kind of the lineage. But I know that this was also standing on shoulders of. Is Travis a giant?
Oh, Travis is definitely a giant of the hardware hacking world.
Yes.
Yeah.
So that's how this kind of came about in your world, right?
Yeah. Right. Yeah, actually, a lot of people should be familiar with Travis Goodspeed's work if they have any interest in hardware hacking, not to mention wireless hacking. But if anyone's familiar with my work, a lot of people know me from designing hardware platforms like Ubertooth and Hak5, and I got my start in hardware hacking because of Travis Goodspeed. The first time I ever soldered, like did a surface mount assembly, it was soldering a GoodFET. It was assembling a GoodFET. Travis gave me the bare PCB at a conference like 10 years ago, like he gave to everyone. He was just passing them out like candy and encouraging people to get into hardware hacking using the GoodFET platform. And I specifically soldered one so that I could interface with the IME, the pink toy.
Oh, the pager.
Yes.
That would later become the evolution of the Yardstick One.
Yes.
So this is all connected.
It is.
That's so cool.
Yeah.
So for people that aren't familiar with a FET as a tool in your repertoire of hardware hacking, you know, your arsenal, what does it provide you?
What does GreatFET provide you?
Let's start there.
All right, so GreatFET is a peripheral interface tool. It's a lot of things, actually, but that's how I've been describing it lately, because what it does is it connects to your laptop or your host computer of some kind and extends the reach of that computer to the outside world.
Right, because the only I/O I have on my computer is like USB, and you know, in this day and age, if you can get a headphone jack, you're lucky.
Right, right. But long ago, computers used to have, like PCs used to have serial ports, and they also used to have parallel ports.
Oh, LPT ports.
Nobody knows what parallel ports are anymore.
No. Game ports.
But you know, in the days before USB, that was how PCs connected to printers, of course, and a lot of people back in like the 80s and 90s, if they were experimenting with electronics and they had a PC, they would often do electronics projects that connected to the parallel port on their PC, because the parallel port gave them just general purpose I/O pins.
Yeah, you had 25 pins to work with, and it was just whatever you wanted. You want to make a pin high, pin low, there you go.
Exactly. But today PCs don't have that. They don't have an easy to use GPIO or general purpose input-output interface like that. Unless you go with like a single board Linux computer, that's where those kinds of things come back.
Right, but then that's just a computer with a bunch of I/O, whereas this is a peripheral to connect to peripherals.
Right. Well, it's a...
or is a peripheral to emulate peripherals in some ways, too.
You can do that, yes. And like a lot of people look at GreatFET and they see something like maybe an Arduino. But it's very different than an Arduino. It's like a super high performance Arduino, except it doesn't give you the embedded development model that an Arduino gives you. Instead, it gives you a peripheral development model.
Yeah, and that's conceptually where it differs, because whereas an Arduino, all of the heavy lifting, all of the logic is being done on the actual Arduino's computer.
Right.
With its peripherals, its interface, all of its GPIO and other connections. In this case, all of the heavy lifting is using your quad-core computer with all of those resources that are then taking advantage of its I/O.
Exactly.
So you get a lot.
GreatFET is exposing I/O capabilities to your computer.
Mm-hmm. And so that's where conceptually a big difference between, say, this and Arduino is, because I noticed the you've got your headers here, and I've noticed all of these other toys that are playing alongside them, and that does make me think Arduino. Mm-hmm. But you're right, you do have to wrap your head around it's this and your laptop as a whole system.
Exactly.
Okay.
Exactly.
So tell me about some of the things that I can do even before I get to some of the add-ons. What are the kinds of things that I can do if I'm curious about like starting to hack with hardware? What the GreatFET might let me do.
So the first and most obvious thing that it does is it gives you general purpose I/O pins, or GPIO pins. Mm-hmm. So, for example, you can plug an LED into your GreatFET and then from software on your host computer turn on and off that LED.
Oh, right. And so since all these I/O pins are 3.3 volt, it says right here on the board, I wouldn't need much more than just an LED stuck into it, right?
Right. Well, you probably want a current limiting resistor. But
okay, I was thinking a 3.3 volt LED, but yeah.
But basically, you can just plug an LED in and it works as long as it has some kind of protection. But it gives you the opportunity to experiment with external things. Maybe you want to wire up to another piece of hardware and probe it or manipulate it in some way.
Yeah, you've seen some of the prototypes on my desk as we're like, building new fun things here. Mm-hmm. And I'm very familiar with using a UART. Just using a very simple serial TTL that allows me to connect to a console on the machine. And that's very common amongst the kind of embedded electronics that we deal with. But I know there's a whole host of other protocols to speak when it comes to like, I want to start hacking my car or start hacking this weird piece of electronics I found,
Right. With GreatFET, we give you the ability to connect to general purpose I/O. We also give you the ability to connect to a UART port. We give the ability to connect to a SPI or an I2C bus or a JTAG debugging interface. There are a whole bunch of different interfaces, electrical and electronic interfaces that we can connect to and expose those to Python on your host computer.
So you said two things that I really love. One is all of them are on one platform. So now I don't have to have a bag full of dongles for all of the various different protocols.
Right.
And two, Python.
Yes.
I love look, I just want to get this thing done. We're not I don't need multi-threaded for what I'm doing. This doesn't need to compile down into assembly to fit on an embedded box. I want to be able to read the code.
Yes.
And interact with it.
Yes. And that's exactly why we use Python. We want it to be a tool for rapid development and prototyping, and something that you can sit down and write a few lines of code and have them be useful, and not have to create a whole large project and compile it and so forth. We want you to be able to plug in the GreatFET, and you can even open up an interactive Python shell. You don't even have to write you don't even write the software into a file. You can just start experimenting from the command line.
Perfect for proof of concepting. You're like, I wonder if I just wiggle this pin and it does the thing, and now suddenly you've hacked your alarm clock, and you're like, okay, cool, now let me wrap this up and turn it into something pretty.
Right. And people who are experimenting today with embedded platforms, even if you're already working with an embedded platform, you can probably see the value of having a rapid prototyping tool that lets you do it on your host computer, on your laptop, in a Python shell, before you actually implement that function on the embedded platform.
Totally. So then what are some of the other, aside from having all of that I/O and all of those protocols under the sun, what other fun, nefarious stuff can we do? With
Well,
GreatFET
the
One?
main things, if you look physically at the board, you'll see there's like a huge number of pins to connect to the various I/O pins and peripherals that are built into the microcontroller. But there's also an extra USB port. There's one USB port that connects, the one you're pointing to there on the convex side of the board is USB 0, and that's kind of the primary port that connects to your host computer.
Okay.
But USB 1 on the concave side of the board is for connecting to a target device or host.
Now you're talking my language, because you know what I love to do is roll up on target, unsuspecting, plug in a little USB thing, and the magic happens.
Right. And now there's this history that goes behind GreatFET. GreatFET was named in the inspiration for GreatFET was the GoodFET platform from Travis Goodspeed, and the name is derived from the GoodFET. And so it's sort of the Great Scott Gadget's next evolution of the GoodFET platform. But it's much, much more capable than GoodFET. But one of the most popular variants of GoodFET was a board called Face Dancer. And Face Dancer was a GoodFET that had an extra USB port, just like GreatFET does. And you would connect it to your laptop that you were working with.
Yep.
But then you would also connect it to a host, a target host, over the other USB port. And then you could do some really interesting USB hacking by emulating a USB device in software on your attack computer, which is a little hard to wrap your head around, I think, that you're actually running the USB device not on this embedded platform, but you're running it in Python on your laptop.
No, I think, especially for this audience, I think that we're very familiar with like the concepts of some of our tools like the USB Rubber Ducky or the Bash Bunny, which will do very similar to emulating trusted USB devices like Ethernet or serial or storage, but all of that is being done on the stick itself, on the USB. In this case, you're saying that I've got my attacker laptop here, I've got it USB plugged into the GreatFET, and then I've got the GreatFET plugged into, let's call this the victim box, the target, and I want to then be able to prototype an attack against your machine. Then I could use this with the interactive Python to be able to convince it that this is a serial device or a USB mass storage or a keyboard, whatever I want.
Exactly.
But the magic is happening on my computer.
It is. And now that may seem like a whole lot of hardware to do something that you could do with something very small, like say a rubber ducky. But a rubber ducky,
totally different concept.
A rubber ducky is a special purpose device that executes, a certain class of attacks. And what GreatFET gives you with the Face Dancer software is the ability to implement any USB protocol under the sun and experiment and maybe develop the next generation of something like a rubber ducky, but that does a completely different attack, for example.
So if I wanted to like sniff the protocol of my, the USB joystick that is the PlayStation controller, right? And I want to figure out the timing to get like 5 stars on Green Grass and High Tides in Rock Band, for instance, I could then program in Python a way to systematically do that.
Absolutely. We've done a fun thing at Great Scott Gadgets where we've been playing with the Nintendo Switch. And actually, Nintendo Switch controllers are USB devices. If you get the wired controllers, they're actually, if you get like third-party wired controllers for the Nintendo Switch, they're USB devices. And we've done like man in the middle on the USB where like you play Mario Kart, but your left and right controls are reversed, and it's great fun.
Oh no, this is brilliant too, because you take that now that you can write a program that can control Mario, then you just give it a webcam and some machine learning to know where the track, and then suddenly it's like you could build like an AI that could play Mario Kart.
You absolutely could.
And that's I love that conception. It's just like the weird stuff you never would have thought of. So you're right. It's very different. Like, okay, so it can type. No. It can be any USB device.
Right.
I want to emulate some very esoteric thing that's only used in this, like, you know, some PLC, right? That's only used in a very specialized industrial setting, you know, that costs millions of dollars from Siemens or the like. I could probably do that with something like this, proof of concept something.
Right. And so we're giving you a tool that you can use to reverse engineer that device in the first place, and also a tool that once you've learned some things about it, you can use to emulate that device or emulate a host. And in that way, you can probe for vulnerabilities, for example, or just rapidly prototype things. Maybe you're a developer of USB devices or hosts. This would be a handy tool for that kind of use as well.
All right, Mike, so I've got the GreatFET One out of the box. I want to get started, get through that Hello World stuff so I can get into the fun nitty-gritty. How do I get started?
Well, I recommend starting with the GreatFET tutorials. And we have a bunch of GreatFET tutorials online. The first one is getting started with GreatFET. And if you look at the GreatFET tutorial, you'll see getting started with GreatFET, the first thing you need to do is just install the Python software. So that's just a pip command, sudo pip3 install. I'm going to give it the ---- upgrade option, which isn't actually required if you're installing it for the first time, but it's a good habit to get into, to just always give it the upgrade option, and that way you can use the same command repeatedly if you want to update the firmware in the future.
So this takes care of all the dependencies and all of the other stuff there.
Right. After typing this command, you'll have the GreatFET software installed, and you can start communicating with your GreatFET. Now there are a couple of other options. Well, there's this one little step here that I'm going to skip, installing UDEV rules, which just lets you communicate with the GreatFET as a non-root user. I've already done that, so I'm going to skip that. And then I can connect my GreatFET One, I just plug it into my laptop here, and then I can type the GreatFET info command, which gives me some information about the GreatFET that's plugged in.
So the GreatFET command is kind of like ADB. You know, you can do like an ADB devices and see what devices are connected to it, and you know the GreatFET command takes other commands.
It has subcommands,
yeah.
Exactly. So that's why we do GreatFET space info or GreatFET space shell or something
just
like
you're
that.
doing ADB shells. Sweet.
Yeah, and it also installs an abbreviation. So GF info is the same as GreatFET info. And if I look through my tutorial here, the next thing it advises me to do is update my firmware. I've already done that, so I'm going to skip that step. But notice that it's just
FW tac auto. What?
Auto.
It just goes to the cloud, grabs the latest, puts it on.
It actually already has it. So the Python host code has an embedded firmware image. It's a very small firmware image that matches the version that's installed. So the firmware always matches the host code if you just run
So the
this.
framework and the firmware are always in sync.
As long as you type this GreatFET firmware auto command.
Nice.
That's right. But I'm going to skip that one since I've already updated my firmware. And then I'm just going to go on to the next section of this tutorial, which is blinking an LED.
That is the hardware equivalent of Hello World.
It is. Now, there is a heartbeat already blinking on the GreatFET One, but we want to make another LED light up. And the way I'm going to do that is by starting up a shell, GreatFET shell. Now, some folks may be familiar with IPython. It's an interactive Python shell. Now, you can just type Python and hit enter and get an interactive Python
the IVR.
shell. Right. But
how does this one differ? I've never used
IPython
this
is
IPython.
just a little bit of an enhancement to the basic Python shell that's installed with every Python installation. So it just gives you some helper functions, like a function called help, for example, and it also gives you tab completion for the
now
Python
you're talking my
API.
language.
Right? And so
that's contextually aware.
Yeah, it is. So now I have with GreatFET shell, it's opened an IPython shell. Plus, it's giving me a GF object, that is the Python object that corresponds to the GreatFET. So if I just type GF, the shell tells me a little information. It just tells me, oh, there is an object of that name, and it is a GreatFET One. But I can do things like GF.LEDs, and I can see that there's actually an array of 4 LEDs. And if I do
And then
exactly...
so can you figure out what you can do with those LEDs with the tab completion?
You can. If I want to assign one of those to a local variable, for example, for convenience, I can just type LED equals gf.leds2, and now I have this LED object, and I can do something like I can just tab complete here to find out what methods it supports.
Ooh.
You can see it supports methods like on, off, and toggle. So I like to use toggle because it's just
because you can run it over and over.
Right. I'll just toggle LED2, and now you can see that LED2, the yellow one, has turned on.
Nice.
If I just up arrow and hit LED toggle again, it'll turn off. And so if I wanted to blink LED a few times, I can do this entirely on Python.
So you can create a while loop, a little sleep, and blinky blinky.
Exactly. I have this right here in my tutorial, and I could probably just copy and paste it and have, in this case, LED3 blinking on and off several times.
Nice.
Yeah.
I love the power of that because it's like, presenting all of the, GPIO and all of the other stuff that you get with the hardware, but then just making it easy so you don't have to futz with anything. You can use something you probably already know, Python, and if you don't, it's really easy to pick up.
Yeah, and this is where I hope people can see the benefit of something like GreatFET as it provides a peripheral development model. It lets people use the rapid prototyping environment of a Python shell or a Python interpreter. It's pretty easy to then take what I'm doing in a Python shell and throw it into a file that's a Python program that you run. And blinking an LED is, kind of hello world, but kind of the next step I usually have people go through is turning on and off a GPIO pin. It's very, very similar to blinking an LED. Mm-hmm. Turning off an LED, it's manipulating the voltage on an external pin.
Which could be connected to all sorts of things.
Right.
Yeah. Okay. And also in the same vein as like the Python here, is the face dancer stuff also Python?
It is.
Okay, so you could kind of almost, utilize both of those things if you wanted to get all fancy.
Right. And that is something that GreatFET provides out of the box, is the face dancer capability. Now, face dancer, once upon a time, was a piece of hardware. The original face dancer was a piece of hardware, and it also had some software that went with it. That was the face dancer that was part of the GoodFET project. But modern face dancer is a software framework that was created by Kate Temkin, and it is an extension of the old face dancer software that supports multiple different hardware platforms. The primary,
really?
Yeah,
okay, that's cool.
Actually, modern face dancer code supports the original face dancer hardware,
mm-hmm.
but it has many more capabilities if you use it with GreatFET One.
Clearly, because you have all of the hardware capabilities of the GreatFET One with its GPIO and SPI and everything else.
Even just the face dancer function is a lot more enhanced because it uses a faster USB implementation, and it uses a more flexible USB implementation. So the USB configuration, if you're familiar with USB endpoints, for example, you have more endpoints available to you. So the repertoire of the kinds of USB devices that can be emulated with face dancer on GreatFET One is much greater than the repertoire of the types of things you can do with the original face dancer.
Great. So with the new hardware, higher throughput, more devices, much easier because you have the more modern face dancer framework to work with in this case, and it's Python as well. Can we interact with it in the same way, or are there like if I wanted to just get started and I want to see some example code of like some fun device emulation that I can do,
sure,
and start like using my whole power of my computer as the attacking machine through the GreatFET One. What kind of example attacks could we do on my poor little Ubuntu box over here?
Sure, let me show you here. If I go into my face dancer source directory, face dancer is a software framework that's built in Python and is and knows how to communicate with the GreatFET API. So I don't actually have to do anything special to be able to just run these GreatFET face dancer example programs. So like I can run one of these example programs here that emulates a serial port, or that emulates a keyboard, so I could play with rubber ducky type things. Or one of my favorite ones is this USB mass storage device. So I could actually create a virtual mass storage device that I could plug in to your laptop, and your laptop will think it has a mass storage, like a USB flash drive attached to it.
And really bringing the flash back into the FET.
That's right. That's right. The GreatFET, the FET part of the name.
Let's do an example of that. I'd love to see that.
Sure. Let's plug this in. I will.
So then I take just a regular USB cable.
That's right.
A regular micro to A.
Yep.
Or whatever.
And so now my laptop's going to attack your laptop. Well, it's not really going to attack it. It's just going to emulate a USB mass storage device just by running this Face Dancer UMass example program. And oops, I forgot. I have to give it the name of an ISO image, which or some disk image that it is presenting to your laptop. So I happen to have an Ubuntu install ISO image.
Oh, good. I've been needing to upgrade my machine anyway.
Yes.
I'm rocking an old version of Ubuntu, so let me get that latest for you.
So I can expose this ISO to you using this emulated USB mass storage device, and you can see a bunch of stuff going by on my screen.
Sure.
Because my program is showing the every individual function, everything that your laptop is asking for over USB. All of those little USB requests get handled by Python on my computer.
Oh, cool.
And
so you're seeing my computer, because it just popped up on my machine as if a regular flash drive, and I'm like,
right.
It's like, oh, hey, new drive installed, and I'm like, cool, but I know it's not a drive. I know it's software.
Right.
So your Python is now able to see everything that I'm doing to this.
That's right. And so this is a really useful tool just for reverse engineering, for example. If I want to know exactly what specific functions your host OS is calling over USB when it's talking to this mass storage device, I can get to know that in great detail using this platform. And if I wanted to mess with it in some way,
right,
then I can modify my behavior on the fly and emulate a misbehaving USB mass storage device. And we've used this to implement some interesting attacks. Actually, this is the reason.
This opens up a whole world of attack, not even just for forensics, but also for attacks, because you're seeing everything that. So if my drive right now, if I wanted to start enumerating these directories, you would see me like looking at all those files. If I started reading a file, you could see me reading. You could probably change it dynamically as I'm reading. Like what kind of stuff does this open up?
Well, one kind of attack that we've played with at Great Scott Gadgets is a time of check to time of use attack. And so imagine for a minute that I'm not plugged into your laptop, but I'm plugging into an embedded device. An embedded device that has a USB port and supports a firmware upgrade function. So this is actually the reason...
We do this to the USB rubber ducky, or to the bash bunny. You put a file on it,
Yep.
you run it, and then it goes, oh, that's my upgrade bin.
Yep.
It verifies that it's its upgrade bin, and then it installs the upgrade. I mean, it doesn't have a USB host port, but it's similar concept.
Absolutely. But in that kind of a case, the bash bunny may or may not actually have enough memory to load that whole firmware image into memory and then verify it.
No, we actually do a little thing where we tack on a little bit of, it's basically like a SHA-256 sum at the end of the file, and then we can actually make sure that the file's not corrupted, because we don't want to be bricking people's bunnies.
Right. And now the bunny is one example, but imagine something like the bunny, but that is a more closed platform. Totally. Something that you're not supposed to modify the firmware on, something that like maybe even has signed firmware updates. And for example, we've had an embedded Linux built into a video projector at our lab, and Kate and Dominic wanted to try this attack on this device, and this is why this device no longer boots. But
so it's a video device that that you would only get the firmware from the manufacturer. I'm assuming.
Exactly.
Yeah.
And so it has signed updates, and when it you're supposed to be able to download an update from the manufacturer, put it on a USB stick, pop it into the device, and it will run its little firmware update
I've done
routine.
this to televisions.
Sure.
I had a Sony TV that
Absolutely.
works this way, where you had to just go in and you had to get it from the Sony website, and I was like, ooh, maybe
Right.
there's a potential for some fun here, but no, because the signing keys.
Right.
And I don't have Sony signing keys.
Right. But the firmware is pretty big
Mhm.
because it's actually a Linux.
Oh.
And the memory on the first
I
pretty small.
I was figuring it was just checking itself and then DDing the whole thing over.
That's exactly what it does. First, it reads the file on the firmware update file on the USB stick to do the signature verification.
Do the cryptanalysis and make sure that it matches what it has. Yeah.
And then it reads that file again to actually load it in onto its internal
Right.
flash memory.
So unless you were able to make an image that had Sony's keys, it's not going to pass that check.
Except you can provide one file when it reads it the first time and does the signature verification, and then when it reads that file a second time, you can give it different data.
Oh my god. I gotta say, you did the old switcheroo.
Exactly. Except
Because
bait
you
and
can
switch.
actually see when the file system goes to read it. You are the file system. So the
Yes.
operating system is saying, hey, I want to read that file and make sure that it has this checksum or it has this signature. And it goes, okay, it has the signature. So then it passes to another function that says, yep, go ahead and upgrade because that one matches. And then when it goes and asks the file system, okay, cool, give me all the bits. You're like, oh, those bits? They're over here.
Yeah. Exactly.
Which is why there's a bricked projector in your house.
That is exactly why. Yes.
That's fantastic. Oh my gosh. Wow, how do you mitigate that? I hadn't even considered that as far as an attack vector. And how would you
Yeah.
otherwise even be able to do that? Because it's not like, I mean, it's one thing to do it on your own running machine. You know, if I was trying to test my own code. But you're talking about a device you're not in control of, and the only thing that you have to interface with it is over that flash drive. That's so cool.
There aren't a lot of ways to solve that problem for a lot of embedded devices that already implement this type of a USB firmware update function.
No, at a certain point, your hardware has to trust your hardware.
Right.
When you can't trust your hardware, who can you trust? Oh, that's terrifying and beautiful. Oh, that opens up so many. I'm even thinking of just like the forensics analysis stuff you could do right now. Like, oh, the virus scanner went by this, portion of memory and said it was all good. Cool, change the memory.
Yep.
Whoa, that's just so nifty. Man,
And
that's just one device type. And there's
It
like
is.
hundreds of USB descriptors, and you can just in Python emulate them
Exactly.
using the power of your full computer.
Yep. And there's a whole framework, the space answer framework, that gives you the ability to emulate absolutely any kind of USB device, and actually even a host. So we do have the ability to emulate a USB host on the secondary USB port, and then be able to interface with some kind of an external USB device.
So you could do the attack, and this is like the backwards of it.
Right.
Yeah.
Now, that is probably less useful for people because they already have a host they can control in their regular USB ports on a Linux machine. But it is a function.
But if it's a
that the
closed down
that
system you're
supports.
trying to diagnose,
Where it really comes in handy is in a man in the middle kind of scenario. Let's say you have a USB device that is not in your control, and a USB host that is not in your control. You don't control the
Yeah.
operating system on either
I'm
one.
imagining like a very proprietary kind of like industrial control system or something that only speaks when its own proprietary thing to their own very expensive equipment. And if only you just knew how they talked.
Right.
Yeah.
Or a more day-to-day example that people might be familiar with is a gaming console and the controllers for that gaming console.
Domain.com has all of your website needs from .com and .net to intuitive website builders. Create your online identity with their affordable, reliable tools. Even brand yourself with over 300 extensions from .club to .space. Domain.com loves Hak5, which is why you get 15% off domain names, hosting, and email when you check out with coupon code HAK5. When you think domain names, think Domain.com. Mike, I've got already so many devious ideas going in my head, and we haven't even broken into half these other boards. I know we're going long, and you guys probably have so many questions, so please leave them in the comments, and I'll wrangle Mike in to hopefully answer some of those. But please tell me about these, and then we'll have to have you back on to really dive into the neighbors.
The neighbors. Neighbors are add-on boards for GreatFET. And we have a number of them in development right now. These, none of them are shipping yet. We've just recently started shipping GreatFET One, but we're going to, in the near future, start producing all sorts of different add-ons. Initially, a clear acrylic enclosure for the device, and an add-on board that gives us some through-hole prototyping capability.
Oh, that's cool. Yeah, here, I'll hold that up.
But
that's pretty cool.
and this is just an example of something you can plug in buttons or LEDs or other components into. I actually like to use it a lot for interfacing with like a chip. Let's say I get a spy flash chip or a sensor chip of some like a dip sensor that I can plug into this little breadboard and then wire it up really quickly to my GreatFET. This board is called Daffodil. All the hardware projects in the GreatFET project, all the individual boards have names of flowers as their code names. So actually GreatFET One is also known as Azalea.
Oh.
So if you want to be cool, you call it Azalea, and you know that's what it's called. But the version of Azalea that Great Scott Gadgets ships is labeled GreatFET One, and the various add-on boards have different names. Like Daffodil is the through-hole prototyping board. Crocus is a wireless 2.4 gigahertz wireless board. Gladiolus here is a board for infrared hacking. Ooh. And it basically implements a software-defined infrared function. And we have various other add-on boards in development for voltage shifting and Ethernet and more USB fun and more radio fun.
That's awesome. And they continuously stack on one another.
That's right. They are stackable. So you can generally put a neighbor on top of another neighbor, and they'll fit together, and you'll be able to use multiple neighbors simultaneously.
That is so cool. I love it. You've got me really curious too about the infrared one, because you're known for software-defined radio, and what is radio but light? And infrared is just another radio-like in some ways, and then not in others.
It's very radio-like.
Yeah,
yes.
yeah.
But infrared is very close to the visible spectrum, so we think of it more as light than we think of it as radio. But of course, fundamentally, it's all electromagnetic waves.
Okay, well, let's dive into that next time. I really want to know more, and I know that similar to all of your other stuff, I see it on here. You said Azalea. If people are like really, those board makers, that want to like get their hands dirty, they can, right?
Absolutely.
Kind of like they can with your Ubertooth One, and you've been doing with your whole line now.
That's right. All of our projects are open source hardware. All of our software is open source software. All of our educational material is open content. We're dedicated to making open source tools, and we hope that one of the things that enables is people experimenting with and modifying our designs and doing something more interesting than maybe we thought of.
Dude, this is so cool. And then also, I know that these are available now all over the world. So if people want to grab one of these, whether they're domestic or you've got folks all over, full disclosure, I mean, you can go back and find a video from ShmooCon with you and I pre-Great Scott Gadgets.
That's right.
The Ubertooth. So you of course can find this over at shop.hak5.org or any of the various other retailers that Mike does business with, and you'll find the greatest info at greatscottgadgets.com.
Yes.
There you go.
That's right.
Yeah. Awesome, Mike. Dude, it's great to have you on. Thanks for just making all of this stuff so simple to get into. I can't wait to get one of these to everybody on the dev team. Just even for finding simple GPIO pins or silly stuff like that. Yeah. So leave comments below. With all that, I'm Darren Kitchen. You know where to find me. Mike, where can people find you on Twitter? And the
At
tubes.
Michael Ossmann on Twitter, and of course, GreatFETGadgets.com.
Awesome, dude. Thanks for coming on. Trust your technologist.